Okay, consider the following hierarchy of exception classes. Which of the following statements are correct for a method that can throw array index out of bounds as well as string index out of bounds exceptions, but does not have try catch blocks to catch the same? Okay, the thing here is to realize that these guys, okay, are all runtime exception. They're all runtime exception. So you don't need to catch them or declare them. The method calling this method will either have to catch these two exceptions or declare them. No, that will be if they were checked exceptions like IO exception, file not found exception, end of file exception. It is okay if it declares just, well, yeah, it is, it's okay. You can say you throw, you don't have to, but you can. It must declare, no, it doesn't. That's a checked exception. It is okay if it declares just the other one, yeah, can do it. And it doesn't need to say anything about them because they are runtime exceptions. Runtime exceptions are not checked by the compiler. Okay. This particular one here, we're going to come along into main, we're going to call M1 down here. And we output M1 starts. So there's an option. That's going to print that anyway. Then we throw a new index out of bounds exception. Okay, that's an unchecked exception. It's a runtime exception, so you don't have to have throws on it. We come up here, jumps out of there, and it tries looking for that exception, and it finds it. So we are going to output 1 then. And then we throw a new null pointer exception. Now, what's important to realize, what this program is very good at explaining, is that the catch clauses that you see along here, they go from the most specific outwards. Because if you had catch exception as the first one, then all the exceptions would go in there and there'd never a chance of getting out to the null pointer exception. So it'd be unreachable. The second thing is that these catch, these handlers, these exception handlers, all relate to exceptions from the try block here. So this is the outer try block, if you like. This catch, this throw new null pointer exception will not go into this one. That null pointer exception is for a null pointer exception coming out of M1. So this one has no home for it. So it's just throwing everything out of kilter now. Okay, you need a little try block around it or something like that to catch it around it actually. So it's not going to go in there. Okay. What it will do is finally has to be executed before you jump out of this method main. Okay. So it's going to say, okay, M1 generates its exception. It goes in here, we output 1, and then we generate another exception. Finally has to execute anyway. So it outputs that. But because the exception here was not handled, the end will not be printed. Okay, so the second one, it'll print M1 starts 1 and 4 in that order. Yes. There's the M1 starts, there's the 1, and then there's the finally. Okay. The last bit here is that end will not be printed. The other one is about the order. Okay. 1 and 2. If you thought that, there's a null pointer goes in there. No, it doesn't. See that return, by the way. If that return is executed, it still executes the finally. Just in case. All right, I'll do one more question. And it's this one here. Which exact exception class will the following class throw when compiled and run? Okay, so you have an int array A referring to null, and then you have an I is assigned A with angle brackets of M1. Okay, and you've got, and this M1 throws an exception. So you've got several different things. You've got a null pointer exception, array index out of bounds exception, exception or runtime exception. And it's all about which gets evaluated first. Is it the A? Is that going to be dereferenced, giving you a null pointer? Is it the angle brackets? Or is it what's inside? This is what's going to have to get done first. You have to evaluate the expression inside the angle brackets before you can do the rest of it. So that means that it's an exception. That one there. It's an exception because the index expression inside the square brackets has to be evaluated first. And when that happens, in this case, we're going to get an exception. And that will then proceed, jump straight out of there. You can see it's up here. It's going to jump with no try-catch block around it. So we have to have a throws clause on main. Otherwise, it won't compile because you have to handle it or declare it. And we're declaring it here. So the next question here is that you're given this public class exception test. And here's main. And it's going to call a method do something. And then it's going to catch a my special exception, which is an unchecked exception. So here's the method do something, and here's the method called do something else. So do something declares an int array, which is of size 4, and then it tries to access the 5th element, which means that you're going to get an array index out of bounds exception. Control jumps immediately from line 12 out of the do something method. This is an unchecked exception, array index out of bounds. So the do something else on line 13 will not be executed. Comes out to here, there is no catch for array index out of bounds exception. Again, you don't need one because it's a runtime exception. So the exception will be thrown out of main to the JVM where it will be output. And the answer to that then is that one there. We'll just double check that. And there it is. Since the length of the array is only 4, you can't access array with index of 4 because that will be accessing the 5th element. Arrays start at index 0. Hence, an array index out of bounds exception will be thrown at line 12. Line 13 will not be executed at all. Since the exception is not caught anywhere, it will be thrown out to the JVM, which will print the stack trace of the exception. And the stack trace is the sequence of methods that got you to that particular spot in the code. There's do something on line 12, which was called from main on line 4 there. So here we have an abstract class, and we have an abstract void method here. Then we've got main, and then we're outputting calculating. And then we set this calculator reference to null, and then we say x.calculate. So that's a null pointer exception. Okay, so it will print calculating and then a null pointer exception. Is that okay? So it's fairly straightforward, that one there. And that's a runtime exception, by the way. The null pointer is a runtime exception which you don't have to put in your try catch block for. For example, there was no compile there without a try or a catch because the null pointer exception is a runtime exception. It's an unchecked exception. So there's a few of them then that are very woolly, shall we say. They're very ambiguous. It takes several readings, and even then you mightn't. I remember when I did my OCA exam, I had something like that as well, trying to figure out what exactly are you being asked. So here's one of them. And I think the best way to just to evaluate it and go through what they believe is the answer. So checked exceptions are meant for exceptional conditions external to the application that a well-written application should anticipate and from which it can recover. Note here that recovery doesn't necessarily mean to keep functioning normally. It means that the program shouldn't just crash. If it absolutely cannot proceed, it should notify the user appropriately and then end gracefully. Exceptional conditions external to the program that a well-written program cannot anticipate but should recover from. So if you can't anticipate it, typically it's a runtime exception for that. Exceptional conditions from which the recovery is difficult or impossible, that's where you use errors. Exceptional situations internal to the application. Okay, generally, if the exception is caused by programs internal, you use a runtime exception. Now, here they try to explain it. I'll just read it, the bits that are important. There are multiple viewpoints regarding checked and unchecked exceptions. As per the official Java tutorial, if a client can reasonably be expected to recover from an exception, and the client here is the caller of the method, it says that down here, make it a checked exception. If a client cannot do anything to recover, then make it an unchecked exception. So the best way I can explain that is that if you're writing a method and your client is going to call you, okay, and you think that the client will be able to recover, then you make it a checked exception. Because if it's a checked exception, the client will have to put in a try block or will have to rethrow it themselves. But they will be aware of this exception now. So if you think they should be able to recover, make it a checked exception. But if you think that they will not be able to recover, then you make it an unchecked exception, a runtime exception. That way the client code will be written without any idea of this exception because the compiler won't force them. And when the exception occurs, they won't have a catch block for it. Okay, so I believe that's what they're getting at there. Another way to look at exceptions is to see the cause of the exception in terms of whether it is internal or external to the program's code. For example, an incorrectly written piece of code may try to access a reference, which is null, or may try to access an array beyond its length. These are internal sources of the exception. Here, using runtime exceptions is appropriate because ideally these problems should be identified while testing and should not occur when the program is ready for deployment. So you don't want a whole load of try-catch blocks for runtime exceptions because it clutters up your code. That's what they're saying there. On the other hand, a program interacting with files that may not be able to do its job at all if a file is not available, then it should anticipate, but it should anticipate that situation. These are external sources of an exception and has nothing to do with your program's code. It is therefore appropriate to use a checked exception here, like IO exception or file not found exception, those kind of exceptions. So if the calling method can recover, throw a checked exception. If it can't recover, throw an unchecked exception. If the internal code issues a null pointer exception, for example, which testing should catch or should weed out, use runtime exceptions. If it's external, like you're relying on a file that's external to your code, use checked exceptions. Okay, the next one. What will the following program print? So here's x is 1, y is 0. X divided by y, you might think, oh, that's a null. You're dividing by 0. But remember that an if statement needs a boolean. If has to return a boolean. So therefore, it will not compile. What's inside a while or what's inside an if has to be boolean. Okay? Number 8 is, this really is an ambiguous question. Java exceptions is a mechanism for, and I mean, you could literally pick any of those 5. Okay, let's see what ones they go with. Java exceptions is a mechanism for dealing with unexpected user inputs. I mean, yes, you know, number format exception is one, but they don't go with that one. That you can use to determine what to do when something unexpected happens. Yes, that would be correct. Okay, now what they say here, exceptions provide the means to separate the details of what to do when something out of the ordinary happens from the main logic. So you have your try block with the main logic, and then down at the bottom, you have your catch blocks. So you're separating your main logic from the error handling. For logging unexpected behavior, once you catch an exception, you can log the details, absolutely. to ensure that the program runs even if something unexpected happens. Well, you could get something unexpected. If you catch and handle the exception, then you can keep going. But they say while it is possible to keep the program running in case of an exception, that is not what exception mechanism is for. Exceptions provide the means to separate the details of what to do when something out of the ordinary happens from the main logic that the virtual machine uses to exit the program when something unexpected happens. Again, you could argue the point for lots of them there. The actual exam contains several questions on exceptions that contain vague statements. It is not possible to determine what exactly is meant by a particular option, and so our answers are based on our interpretation of the options. To answer such questions, we recommend that you go through the following trail on the Oracle website. Okay, so we've got a method here which has a try, a catch, and a finally. Remember, finally will always be executed. Okay, and then we've got a piece of code down here. So this is a very good example because it'll explain exactly the flow of control with or without an exception. So let's call method with passing in a 1. So I becomes 1 here. Okay. So I is now 1. So try the following. If I is equivalent to 2, it's not. So you add on 1 onto j. Now we're inside in a static method, so that better be static, and it is. So that's that. We got no exception. So finally is going to get executed. Anyway, always is, regardless of whether an exception or not. So we get 3. And then because we had no exception, you could handle the exception, you still end up down here. You end up with 4 as well. So when we put in 1, the if statement was false. J plus equals 1 was executed. We went down to the finally, we added 3, and then we added on 4. So that's 1, 3, 4. Then we pass in 2 on the second invocation. If I is equivalent to 2, you throw a new exception. So you bypass the 1. You jump into the exception handler and you put on 2. You do a return. Now, finally still has to execute. So before you return, finally will be executed and 3 will be added. But because you did a return here, you now will not go down and add on the 4 because you did a return there. So the answer is 1, 3, 4, 2, 3. 1, 3, 4, 2, 3. So you come in with 1, no exception, 1, 3, 4, came in with 2, throw the exception, 2 gets added on. Now you're going to return, but finally has to get a chance to execute, so 3 gets added on as well. Had you not done a return here, finally would be executed, and because you've the exception handled, 4 will be added on as well. Okay, normal control will proceed if you handle the exception. If you don't handle the exception, then it doesn't, it just jumps out of the method. Okay, and the next one here. Okay, so here is k set to 0. I is assigned 5 divided by k, so k is 0, so that's divided by 0, arithmetic exception. So it jumps in here, the arithmetic exception, and it outputs 1. It then goes down to finally, because it's handled the exception, and it outputs 4, and then finally it outputs 5. So it'll print 1, 4, and 5 in that order. So it's not going to jump into this exception and then go down into this exception and then go down there. It goes into one of them, and then it goes into the finally. And they need to be coded the most specific outwards, which is correct. If that catch exception was up here and the arithmetic exception was down here, the code would not compile because everything would go into the catch exception up here. And the catch arithmetic exception, if it was down here, wouldn't be reachable then.